Dear students, today I'll discuss with you some important points from the chapter chemical equilibria or chemical equilibrium. Okay, first point, for a reversible reaction at the equilibrium state, the concentration of the reactants and products do not change with time. Okay, so what point you have to remember? Do not react concentration. The concentration of the reactants and products do not change with time. Okay, the equilibrium state of the concentration reactants and products do not change with the time. So you have to remember concentration do not change with time. Second, at the state of equilibrium, temperature, pressure, composition, color, density remain constant virtually. Example, in case of evaporation of water, vapor pressure of water becomes constant because the concentration of the substance becomes constant. Okay, so at the state of equilibrium, temperature, pressure, composition, color, density, okay, these factors remain constant. Next point, relation between Kp and Kc. This is equilibrium constant in terms of concentration, and it is in terms of partial pressure. So this is the relation. Kp is equal to Kc RT delta the power n. Okay, delta n, power delta n. What is delta n? Delta n is the difference between the concentration of products and reactants. Okay, suppose you are taking 2 molecules of A, 3 molecules of B, giving 4 molecules of C. So your if delta n is here is 4 minus 5, that is minus 1. Okay, so you will get this is delta n. Okay, next, effect of temperature on equilibrium. What is the effect of temperature on equilibrium? So there are two types of reactions. One is exothermic reaction, another is endothermic reaction. So in case of exothermic reaction, in forward direction, increase in temperature, the Kc value decreases. Okay, simple. You should not go to the direct the equilibrium. You go to the exothermic. Heat A plus B giving C plus heat, delta H. Okay, heat is released here. So when heat is released here and you are giving heat to this side, increased temperature means what? You are giving the temperature to this side. So then the reaction will not go to the forward reaction. Okay, when heat is released, if you remove the heat, then the reaction will be proceed forward. This is simple. So exothermic reaction, Kc value decreases if your temperature increases. Okay, in case of endothermic reaction, in backward direction, increase the temperature, the value Kc increase. Okay, yes. Next, then comes to Van 't Hoff equation. What is Van 't Hoff equation? It shows the quantitative relationship. Okay, Van 't Hoff equation here shows the relation, quantitative relation between what? Between equilibrium constant and temperature. Between equilibrium constant and temperature. So this is your say equilibrium constant and this is temperature. Okay, so you will get d ln Kp by dt is equal to delta 0 RT square. Okay, if you remove this ln to log, change ln to log, you will get log Kp Kp2 by Kp1 delta has 0 2.303 RT T2 minus T1 by T1 T2. Okay, T1 T2. So this is the relation you have to remember for problem solving. Next, what is rate constant? What is rate constant? Rate constant is the, suppose rate of reaction is direct proportional molar concentration. Okay, so omitting this proportionality sign, you will get is equal to Ka. This K is known as the rate constant or velocity constant. So you have to remember rate constant is same for velocity constant. You should not confuse rate constant and velocity constant, both are same. Next, Units of equilibrium constant Kc. Units. What is its unit? When total number of moles of the product is equal to the total number of moles of the reactant, then K has no unit, because it is the ratio of the products to the reactants. Kc, what is Kc? Kc is the ratio. Kc is the ratio of product by reactant concentration raised power its molar coefficient. Suppose it is N and this is M. So this is Kc. So this is the ratio. If both these side, reactant side, product side, both are same, then you will get no unit. Next, the application of equilibrium constant and reaction quotient. What is reaction quotient? You see, reaction quotient, to know, we will do a problem. So prediction of extent of reaction, larger the value of K, greater is the equilibrium concentration of the components on the right hand side of the reaction as compared to those on the left hand side of the reaction. That is, the reaction proceeds to a greater extent in the forward direction. Okay, so we'll do see the example. 2NO2 gaseous state giving nitrogen gas plus oxygen gas. So at 298 Kelvin, the K value, equilibrium constant, K value is given this much. So what is the concentration? You see, K is equal to N2O2 by NO to the power 2. So here N2O2 is you are very small, because this is minus sign, this is the minus sign, therefore it is very small. Okay, another example, take 2CO plus O2 giving 2CO2. So here at 100 degree centigrade Kelvin, K is equal to this much. So here K value is very large. Okay, this is positive side, this is positive. Okay, so where the value is positive, K value is very large, so CO2 is formation is very large. That means reaction goes to the forward direction. If value is minus, very small, then the reaction will go to the backward direction. Okay, next, prediction of direction of reaction. For this reaction quotient, use calculated. QC is equal to C the power this is the equation, quotient, reaction quotient. QC is equal to C to the power M D the power N by A the power X B the power Y. Okay, so in terms of partial pressure, this is written like this. So at equilibrium, what happens? QC is equal to Kc, that is equilibrium quotient is equal to equilibrium constant. If QC is less than Kc, when it will happen? When the reaction will proceed in the forward direction. When reaction will proceed in forward direction, then Kc is more. If reaction will run a reverse reaction towards reactant, then QC is more. Okay. So example, to identify the difference between QC and Kc. So this is the given equation, H2 plus I2 giving 2Hi. Here the molar concentration of H2, I2, Hi are given 0.1, 0.2, 0.4 moles per liter respectively at 783 Kelvin. If Kc is 46 at 783 Kelvin, predict the direction of the reaction. You see, calculate QC, put all the values, you will get 8. Okay, so your Kc is 46, Kc is 46 and QC is 8. So Kc is greater than QC, therefore the reaction will proceed in the forward direction. Okay, understand? Okay students, have a good day.